Okay, let's unpack this. We've all dealt with it, right? Video cables that promise these amazing resolutions, but then they just choke the second you try to run them more than, I don't know, 20 feet.
Exactly. They just give up.
So today we're looking at the engineering that actually solves that problem. We're doing a deep dive into the tech inside the DVIGear DVI-2840-AOC Active Optical Cables.
And our mission really is to figure out how they make the impossible possible. How do you push just a massive amount of data the length of a football field with zero degradation?
Let's start with those headline numbers, the throughput. We're looking at an aggregate data rate of up to 32.4 gigabits per second. I mean, that's just a staggering amount of bandwidth.
It is.
So what is the DisplayPort 1.4 HBR3 standard actually doing for us here?
Well, HBR3, that stands for high bitrate 3, and it's the key that unlocks that speed. At 32.4 GBPs, it just means versatility.
Yep.
You can drive 8K resolution, that's 7680 by 4320 at 30 hertz, which is, perfect for things like CAD or really detailed static displays.
Right, where motion isn't the priority.
Exactly. Or if you need that super smooth motion, say for live broadcast, it can handle 4K at a blistering 120 hertz.
And all of this over runs up to 100 meters.
100 meters, that's 328 feet. And that distance is precisely where copper it surrenders.
Okay, so this is where it gets really interesting for me, the technology. It's an active optical cable, an AOC, and it uses a hybrid design, 4 glass optical fibers for speed and 6 copper wires. Wait a minute. If the glass is doing all the heavy lifting for speed, why do we still need those 6 copper wires? Are they just for, legacy stuff?
That's an excellent question. No, that copper is absolutely essential. It handles all low speed control, the configuration data, and maybe most importantly, power delivery. And by routing that main video signal entirely through the optical path, you get this huge advantage, especially in professional or sensitive environments. It's completely immune to environmental RFI and EMI, radio frequency and electromagnetic interference.
So if you're running this cable near, say, heavy machinery or in a high-security building, that immunity means you don't have to worry about ghosting or signal dropouts.
Not at all. It's a huge headache solved.
And when we talk about reliability in those kinds of environments, what's the actual lifespan we're looking at for this fiber?
The engineered reliability is it's pretty remarkable. The mean time between failure, MTBF, is rated at over 150,000 hours.
150? Wow, what is that in years?
That's nearly 17 years of continuous 24/7 operation. This cable is basically designed to be installed and then completely forgotten about.
Set it and forget it.
And for convenience, the whole thing sips power. We're talking less than 0.43 watts, typical. And it draws that power right from the DisplayPort source, so you can forget about that bulky external power supply.
That low power draw. That brings us perfectly to the physical design. I mean, if it's going to be maintenance-free for 17 years, it has to be tough enough to survive the actual installation.
Right, and it is. They're plenum rated, which is a big deal for fire codes, and they're highly flexible. They've got a minimum bend radius of just 35 millimeters.
That's tight.
But the engineers had to get really clever to solve a big physical challenge. How do you pull a big, chunky DisplayPort connector through a narrow conduit?
Right.
The trick isn't making the wire smaller, it's making the connector removable.
So you pull the cable through, first using that tiny connector profile, and then you attach the full-size head.
Precisely. The cable terminates in these tiny mini DisplayPort connectors. They're less than 8 by 11 millimeters. Once it's routed, you just snap on the full-size detachable DisplayPort docking connectors.
And I see they have a locking pin.
They do, yeah. For security, to stop accidental disconnections, especially in really dense server racks or control rooms, it's just a clean solution that ticks every box DisplayPort 1.4 HDCP, even TAA compliance.
So what does this all mean for the user at the end of the day? The promise here is just seamless long-distance signal extension. Flawless image quality.
And not just video, right?
Not just video, no. Even the audio path is built for lossless broadcast quality sound. It supports up to 32 channels of uncompressed PCM audio. It's a real technological leap, all inside a flexible jacket.
Yeah, and if we kind of pull back and look at the bigger picture, this reliance on light is transformative. So here's something to mull over. Given that the entire critical video signal travels only over optical fiber, how does this complete immunity to environmental noise fundamentally change our approach to long-term digital signal security and critical infrastructure, especially when you compare it to those vulnerable traditional copper systems?